Hello and welcome to the area webinar. Today is October 29th and my name is Christine Perret. The topic of today's webinar is why and how to introduce enterprise augmented reality. I'm going to open today's webinar with a few slides just to set the context, and then we'll be moderating a panel discussion. Today our panelists include Paul Davies, senior engineer at the Boeing company, focusing on manufacturing engineering across the product lines. With us today is also David Doral, Vice President of AirTech Solutions. AirTech Solution provides services and experts for manufacturing, also in the disciplines of aerospace and aviation. We'll be hearing from a little bit more about that from David. Patrick Ryan is the Director of Augmented Reality at Newport News Shipbuilding, where he leads all augmented reality initiatives across the company. Finally, Joseph Metzger here from Johnson & Johnson Vision Care is going to be also talking about augmented reality in the manufacturing sector. So, gentlemen, thank you for joining us and to share your experiences with us. We know that every company is unique, and some of the richness of what you're going to be explaining to us today applies primarily to your companies and your situations. But there are patterns that we can identify, and your guidance will be very valuable to those who are just getting started. Speaking of getting started, I'd like to let everybody know that we are recording today's webinar, and I'm going to get started with a few slides to explain the background and the context and how the area thinks about enterprise augmented reality. Well, it really all builds upon an enterprise IT system. You see, the IT systems today in large enterprises are getting deeper and richer, and they are investing. They're great investments. They're fantastic and highly leveraged information, data. So big data is a big theme. And of course, we need to have better ways of extracting meaning from all that information, all that sensor data, and other types of analytics. Augmented reality is one of those ways of extracting value from a deep information system by bringing to the user the most relevant data at the time when they need it. Not just the relevance is important, but also that it's being drawn from the freshest source. So the context is highly important, especially for those who are performing rare and complex tasks. When you have rare and complex tasks and you can refer quickly to the best information about to help you make decisions, you can reduce the time to perform those tasks. You can also better utilize limited resources, and those resources might be energy resources, they might be water or materials, but they can also be human resources. And by having remote guidance and remote experts available to people who are out in the field, who are dealing with situations they've never encountered before, having augmented reality assisted systems to help with that can be a great time saver. In fact, you can also reduce errors. So augmented reality across the board is being demonstrated to reduce errors due to either miscalculations or lack of information, lack of training on the part of the people who are performing tasks. Many industries that use augmented reality, and including those of the companies that are represented here today, are highly regulated, or they may have very, very rigid policies internally. So there can be public policy as well as internal policies. And augmented reality can help to capture, record, and certify that the policies are being followed and that the company complies consistently with those. When you reduce the time to perform complex tasks, and you can reduce the number of errors and increase the use of resources and compliance, all of these things go to the bottom line and reduce costs. So the lower impacts of task reduction, time to perform the task, and the errors all help to build this improved operational efficiency. Now, our organization is built right on these ideas, these concepts. Our vision is that a global mobile member-based organization accelerating AR adoption is going to help people get to that workplace performance. It starts with the customers. The customers and their requirements are really at the center of the area, and I think of augmented reality. Their use cases, highly diverse, very complex, but they are increasingly able to talk about their needs, their requirements to the providers of technologies. The providers of technologies need to hear about those so that they can customize and provide the best components and systems, as well as customized or off-the-shelf services. In addition, when we formed this organization, there were at the table the non-commercial entities. These include trade associations, standards associations, universities, and research institutes that can help to solve some of the problems that both the customers and providers share, including getting a good message out and making sure that there's not a lot of unmet expectations. So the area is built of customers as well as non-commercial entities and providers. Together, we represent a new technology ecosystem that really hasn't existed before. These different segments of the technology ecosystem, the area ecosystem, the AR ecosystem, including customers, non-commercial entities, and providers of technologies, collaborate in order to produce better integration of components. Higher performing systems can lead to better customer outcomes. So the bottom line for us really is to help the customers choose technologies well and to integrate them quickly so that they can have good AR benefits. We are a young organization with 22 members. Very pleased to welcome you to this webinar on behalf of all the area members. Some of them are, as we said, large enterprises. Some of them are very small companies, but all are welcome, and we're working together to get enterprise augmented reality across the trough of disillusionment. This is the Gartner Group hype cycle, and if we work together, we feel we can reduce the time and reduce the pain that many people will experience during this disillusionment phase and get more quickly to the time when we can use augmented reality productively. So with that, I'd like to go ahead and transition over to the panel discussion. Thank you very much for your attention.
And placing digital information on something that you're working on, a unit that you're working on, is tremendously helpful for the frontline craftsman. So I think just to put some contrast into what Paul talked about, using it in a low production rate, high variability manufacturing environment is very, very powerful for us.
Thank you. David Durrell, would you like to speak about the AirTech initiatives, who your customers are?
Sure. I guess that yeah, our interest probably comes from an extension of things that we've already heard, because in the end we also work in the same industry as Paul, aerospace industry, and as such, yeah, well, this industry requires of highly skilled and trained engineers and technicians, despite all the automation, particularly given that, as mentioned before, aerospace is not I guess a fast-paced industry in terms of yeah, the rate of production is not particularly high. The human component, the human element of production is still very important. One of the things that we do is provide technical support, expert technical support to complex operations like the assembly of aircraft in final assembly lines. As such, we think that AR can accelerate training, particularly when we're dealing with these skills that, as I said, are not easily gained, easily acquired. By combining, by merging or blending the real world with the digital world in a very intuitive fashion, I think that that training process is highly accelerated. And again, we need to emphasize the fact that the digital world is really important and is a typical tool for us given that nowadays any complex design is done in the CAD packages. I mean, it's done in the virtual world, so to speak. And there are things like the digital mock-up of a whole aircraft that is always a tool that you need to use. And AR also can help us spread the know-how, spread that knowledge, not just as a training, I guess, tool per se, but also as part of our service. Before we mention also the remote support, the expert remote support, just by making use of that tool, of that approach with the enhancement that AR can provide, it can help us to extend that knowledge while we provide our service, our technical support service, typical service, because again, it can enhance the experience and it can enrich that experience to everyone that is close to that support and help other more junior individuals learn about the basics and the complexities of things like this, or complex technological products like an aircraft and the process of assembling parts of it.
Thank you, David. Joe, do you have anything you'd like to add about what's driving Johnson & Johnson, some of the motivations you have for looking at this technology more closely?
Sure, real quick. So J&J is a very large company. It's made up of three sectors: pharmaceutical, medical device, and consumer. And out of those sectors, we have well over 100 manufacturing plants worldwide. So we have a lot of opportunity for using this type of technology. Unlike some of the previous speakers, we have a lot of high volume that runs through our manufacturing plants. An example would be our contact lens manufacturer that produces hundreds and thousands of contact lenses in a shift. So we have a rapid manufacturing process. And with AR, some of the motivators that we see that can help drive this technology is several SKU changes. We have SKU changes that are happening constantly, and there's thousands of different SKUs. We can use this technology to help identify different parts that need to be replaced prior to a SKU change, during the SKU change, to ensure that the SKU change was done correctly. And we can also use the technology to help identify parts on the line that we have that need to either be replaced or just to be adjusted, whatever the case may be, because our manufacturing lines, the majority of them are very complex manufacturing lines that are custom built. And it takes quite a long time for our technicians and operators to come up to speed and familiarization with these things. So we see AR as a platform that can help accelerate the learning process.
Great. Thank you, Joe. Thank you, gentlemen. Those were great introductions to your companies and the ways that augmented reality can help. I think we're going to go through some other questions. I want to just very quickly ask, what are some characteristics of the champions? Who are the people in your organizations that are really chomping at the bit, or that saw the potential quite early and taking a leadership role in your organizations? Patrick, I know one of the early leaders in your company. Could you tell us what are the characteristics of a good champion for AR?
Sure, and I think it's twofold. AR is a technology that needs to be supported, I think, by an engineering organization, and that's where most of the people on my team came from. But the champions, the people that want it, are the fundamental owners of the product management, the people that build things. So it originated in a submarine program here at Newport News. And the reason that engineering got really interested is because it changed the engineering process. We design everything in 3D CAD today. And when we use those 3D CAD models at the end of the day as a big engine to produce two-dimensional drawings, and that's a communication medium to the skilled craftsman. In a sense, we've kind of left the waterfront behind, right? We haven't given them access to that 3D model, and that's where engineering got really interested. If we could give the 3D CAD geometry to build directly from, that was a huge game changer for us. It takes a ton of cost out of the engineering process. And so from a champion standpoint, we get engineering wanting to take their non-recurring engineering cost out by not producing drawings. And then the people that build things, of course, can build faster with AR can build faster from the 3D models. And so, of course, they are also folks that are very engaged in getting the technology into the workforce.
Paul, would you say that's a similar situation at Boeing? I do want to go on to David and Joe, but it seems like you and Newport News have a lot in common. So, do you think it's similar at Boeing?
Yeah, I mean, I would say it's really, to be honest, it's pretty easy to get champions with this technology, because when you go up to a program manager or an executive and you say, the thing that, that I'm working on, this technology can reduce your program cost, it can help you stay on schedule, they instantly want to know more about it. I had that opportunity with one of our vice presidents recently, and I had like 20 minutes with him. I was able to show him some of the pilots we're doing, and when you explain what augmented reality is, people understand it. When you show it to them, their face lights up. And I saw it on his face, and he had a big grin ear to ear, and he instantly saw what it could do for our programs, and now I have a new champion. So we need people who see the big picture, understand what the challenges are today, understand enough about them to know how to address them, and also somebody who has influence over budgets, right? Because we need budgets to support what we do. So when you find those folks, hang on to them would be my advice.
Great. David, you're looking for those people in your customers. Can you tell us more about who you're looking for?
Well, obviously, it needs to be people closer to the manufacturing environment that we live in. Yeah, we have to say that definitely the wow factor helps a lot, because it's a very visual technology, as has been mentioned before, and very quickly with the technology that is out there, you can at least attract the attention of many people. But I guess that the challenge here is once that wow factor fades away a little bit, you always need to find for the people with the vision and the tenacity to make of that vision something practical, because in the end, as most business have to suffer, we need to have a positive impact on the bottom line, and in our case, in our production lines, and with higher quality levels and lower errors and things like that. But that persistence and that willingness to try something new, particularly in a conservative environment like the aerospace sector, is some of the key attributes that we need to find on champions.
Okay, thank you. And Joe, you're finding champions yourself in the products, in those factories in different geographies. Where do you go looking for champions?
So what we do here is we've gone ahead and partnered with mainly the business unit managers. These are the mid to upper level managers within the manufacturing plants. If we get their buy-in, then it's pretty self-explanatory to go ahead and actually show the plant managers and the senior managers where the benefit is, because these are the people that are actually living on the line from day to day. And if you can get their buy-in and you can show them there's a real ROI with this technology, then it's a pretty easy sell to upper management.
Good. Well, we'll talk about ROI in a moment. Great way to segue. I'd like to ask each of you to, some of you have already mentioned, for example, Paul, you already mentioned the first use cases around wire harnesses and so forth. Patrick, what was the first use case at Newport News Shipbuilding? You said in the submarine, but was it assembly? Was it inspection? Can you tell us a little bit more about that at Newport News?
Yeah, sure. The first use case that we ever deployed AR on was inspection. So that's where you are looking to see if all the pieces and parts are present and in the right location and in the right orientation. And a geometric overlay on a real part is a real mature, from my perspective, a real mature use case for AR here at Newport News. A couple other early ones were some assembly type use cases. We call it work construction, and also training. Training is if you look at AR as a new method of communicating, it's really engaging, and it's a really great way to deploy to students, primarily on a practical side where they're actually working on something tangible whereas VR might shine a little bit better when you're in a pure classroom scenario. But those are the kind of the three use cases for us that were first used.
All right. Good. David, you mentioned when you were speaking about champions and what you do that you're proposing one of the first use cases being remote guidance. Can you tell us a little bit more about what you mean and what the use case is?
Yeah, sure. As part of our typical service of providing that expert support to complex assembly processes in final assembly lines, way to provide that service in a more efficient way could be through centralized teams with experts from any relevant technical discipline that could provide that service remotely to different plants, different customers, different facilities at the same time. We're doing that through, I guess, enhanced versions of what we could call a video conference tool. Using AR will make that communication much richer. It will be much easier to provide guidance and indications to technicians, on site. I mean, near the assembly of those aircrafts, because you will be able to give those directions, combining again the real world with information provided by the digital mock-up of that aircraft, that system, or that structure. That is a typical case for us that we would like to try in order to prove the value of AR. But at the same time, we need to we need to make sure that the technology and the customer in that particular case is ready, so that we don't disappoint them, and we don't I guess we're sure that those expectations are met in order to keep the bar high and go to the next level.
You did a really good job of transitioning to the next topic, which was the steps that your engineers or project managers follows to study the suitability. So you have to test and see that the technologies are mature enough and make sure that the use cases are clear for that remote expert as well as the person who's on the line. Are there any special steps that people take at Boeing? Paul, are there some special steps that engineers or project managers follow before they deploy augmented reality?
Yeah, there's some preparation that we like to do before we engage a new program, and typically it's we would start with an introductory demo to get people up to speed. But from the program point of view, we have to work with them on getting their digital data ready. And that can be anything from, if we're, in the best cases, taking what they already have in terms of, like a product design or something, and we'll help them get that into our tool. But some of our programs don't even have any 3D data, like our legacy programs. So then, of course, it gets more involved, and we may reverse engineer something or scan, create a low resolution scan of parts to show them, or maybe we create some overlaying content that doesn't use models. It's just kind of text banners and callouts and things like that. And then, of course, when they start using the tool, I always like to have somebody on site as like a focal. So I'll always try and get somebody from the program or from the local IT group to be able to understand the tool at a higher level than what the end user does, so they can troubleshoot it if there's any issues with it, and be kind of the point of contact for that tool.
Good, excellent. Patrick, at Newport News, you've developed a real workflow, I'd say something quite advanced that you use to evaluate the suitability for AR. Can you tell us a little bit about that?
Sure, and a lot of ours projects start similar to the way Paul described with the demo and talking to the folks, but in a lot of cases, AR is not a one-for-one replacement of an existing process. You have to, we'll engage an industrial engineering style team well-versed in AR technology to go look at what people are doing today with tape measures and rulers and drawings and what their process looks like, and then kind of approach it almost from a clean sheet perspective, understanding that AR technology is a completely different new approach for communication and where can it be used. So there is a very fundamental industrial engineering process review before we go and engage a project. Now, I got to say that when you start, there's many times where you'll see a project that you say, "Oh, this is great for AR," and then you get into it and you find out, yeah, not really actually. We're not seeing the savings that we expected. And then there are other projects where you're like, yeah, I'm not sure that AR is well suited to it, but let's give it a try. And then you find something very serendipitous, and it's an amazing technology, and that just comes with experience using it. And so we try and we attack these projects. My team is staffed with people with a lot of industrial experience, and then we train them in AR rather than going and finding AR experts out of school and then trying to teach them industrial processes. We find that it's more effective taking people that know industrial work and teaching them the tool rather than vice versa.
So a couple of times I've heard our panelists speak about having people on site, people who understand the process well and can design as well as follow up after the first introduction. That's really valuable. Thank you, gentlemen. That was good treatment of that subject. I'd like to have Joe begin with this question on slide 12. Was there something about the first or an early AR project that caught any attention of senior management or caught yourself? Is there something that you think stands out that other people should pay attention to as well?
I think the benefit of actually demoing this technology to senior management and those business unit leaders that I talked about earlier is critical, because I see their eyes open up, and one of the use cases that we walked away from was the fact that they could have a lines change over time and reduction of a magnitude of from minutes to possibly several hours, just using the technology to be able to quickly identify parts that need to be changed for the next product, and ensuring that they're also in the correct location. We've also looked at we've gotten requests for putting like work instructions, not only on Google Glasses, but also certainly with some of the technology that we're currently using for augmented reality with our iPads. So there's been a lot of requests and a lot of interest from the management side.
That's really interesting, because you spoke about the different platforms for delivery. I think we've all had to struggle a little bit with that very very point, that maybe the glasses, the head-mounted displays catch the attention of people, get them all excited, and then the technology, the hardware isn't quite as mature as they would like. And Patrick, do you guys use head-mounted displays, or do you still use tablets? Is there something about those projects that make them make it important to stay grounded?
Yeah, absolutely. You can't, if you feel a technology that isn't ready to someone that has to get their job done, and you don't help them, then you're going to lose it all. You're going to lose your ability to make traction and your ability to get adoption. At Newport News, all of the in excess of 40 projects that we have fielded have all used tablets. I have 5 or 6 different head-mounted displays in our lab that we're doing R&D on, but to date we have not fielded any head-mounted displays into the workforce, just because of battery life and heat and wire tethers and ASTM safety ratings and a myriad of different issues that heads-up displays still have to come through. But that's not to say that AR isn't ready. AR delivered on a tablet can be really, really effective.
And can catch the attention of the management if you can show an ROI from realistic deployment, and they're much less expensive.
Yes, absolutely. Our first real project that of any duration, I've briefed this in the public before, and I shared this value. We saved 2.5 hours a day on a single craftsman over the period of 10 weeks. A 35% cost reduction in his time definitely catches management's attention.
Great, thank you. So I'm going to ask now, how do AR project managers collaborate with groups within an organization or outside the organization? I'm on slide 13. Paul, who do you communicate and collaborate with, and how do you go about it? And then I'll ask Joe to go next.
Well, I work with folks both on my team who are intimately familiar with augmented reality, as well as people who are not familiar with it inside Boeing. In addition to, we have our consortiums or memberships of around the world and university partners. It takes a real cross-discipline team to develop and deploy an AR system or pilot. You need people who can write code. You need machine vision experts. You need sometimes you need artists, 3D artists, if you want to animate things or create content. I still believe there's a lot of basic research to be done in terms of like tracking technologies. So we typically would engage universities on that kind of topic, and we have some contracts with both U.S. and international universities trying to solve some tracking problems. But then also, things like consortiums. We're a member of the AMRC. We have research projects that we're funding there, and of course, the area is a really important thing for us to try and solve some of the problems that are specific to maybe industrial or enterprise adoption of AR. So we collaborate with the area also.
Okay, and Joe, is there a lot of also collaboration internally, and how do you see outside your organization? Where do you find experts in augmented reality?
So internally, someone normally would reach out to probably the IT group within our organization. There are a few different AR initiatives that are going on within Johnson & Johnson. And the manufacturing mobility team that I am in charge of, we go ahead and we have a very large presence within J&J, and we would also be a conduit for communication with this technology, and we have been. But outside, we do have some partnerships with the local academic world, and we've got some pretty big initiatives there. But certainly, the Area Foundation has been a big help, which is obviously one reason why we're very motivated to be part of this organization, and it's led to a lot of different collaboration within really experts within this field, and coming up with different types of use cases and benefits of where we can use this technology, and also vendor selection and those kind of things. So we rely heavily on the area group.
Great, thank you. Well, let's talk about impacts. Once you've deployed, once you've started to get past the initial pilots and proof of concepts, Paul, you've done you have mentioned, and you've done some studies. I was wondering if you can summarize how you measure the impacts of augmented reality. Of course, if you want to throw out some savings, time savings, or error reduction data that you've estimated, please share that with us. And then I'll ask Patrick to follow up about measurements that you're doing there. You've already mentioned one, but Paul, go ahead.
Okay, thanks. So I've mentioned a study we did with Iowa State before, so I can give a brief overview of that. It was last year, and we set up a controlled study where we compared different modes of delivering work instructions to people to build something. And the three modes were receiving 2D instructions on a desktop computer. The second mode was 2D instructions on a tablet computer, and the third mode was our augmented reality system. And it was the same instruction, but it was just presented in 3D using the immersive AR techniques. And we ran just under 50 people through this controlled study, and every person built an assembly, and they were graded on the quality of the build and the time. And we found that the quality of the build, when we compared the desktop computer, the first time someone built it with a desktop computer, to the augmented reality system, the quality was improved by over 90%. And these are people who have never, they may not even have a technical background. They were just taken from the university campus, given the system, and asked to build this assembly that they'd never seen before. And most of them, by far, built it without any mistakes from the first time. But not only did they build it to a higher quality, they also built it approximately 30% faster than those who were using the 2D desktop instruction mode. So that was obviously very powerful for us. What we're trying to do now is to realize some of those savings on some of our programs. So we have these pilots out there, and I think we're pretty much on the cusp of being able to compare kind of post-pilot performance to pre-pilot performance, so we can actually get some hard data, some actual relevant data from our production programs on what implementing AR has done for them.
Great summary. Thank you, Paul. Patrick, you've got 40 projects or something. You must use many different metrics to express impact.
Yeah, and there's most of the time clients, I hate using the word customers internal to our own organization, but the people benefiting from AR will tell you what they're looking for. And it's not always cost. Most of the time it's cost. Sometimes it's schedule, right? If it costs them a little bit more, but they can do it twice as fast, that impacts downstream production and benefits the holistic cost, but they're focused on schedule. And sometimes it's quality or safety. Usually we will measure impact on man hours, on cost. I mentioned one already on the other end of the spectrum, and the other one I share in the public domain. We did the first one I mentioned, the 35% cost savings was an instruction use case. On an inspection use case, we did 36 hours of inspection. The traditional way is 36 hours worth of work in 90 minutes using AR. So that's a tenfold increase, which reflects what Paul saw in his academic study, and a well-managed AR project can deliver results like that. But what I will say is that those results are all one-off demos. Right now, where my management sits and where I think a lot of people think about AR is, yeah, show me a demo, 90% or 35% or something in between is great, but what happens when you take it to scale? And right now, that's still an unanswered question from our perspective. We've not taken AR to the kind of scale that we work. I mean, I've got 17,000 shipbuilders, and I don't have 17,000 people using AR yet, certainly. So that's actually kind of the big question out there that we're working to go answer and to go accomplish, and to get the momentum to go fund and go execute a project like that. On the shipbuilding side, we have a saying: if your head, your heart, and your gut are in alignment, you're probably on the right track. And in a lot of respects, we live by that as well.
Great insights. Very organic. Do you have anything you want to add, David, about what you perceive to be the important metrics? I know one of the things I talk about is saving resources. So how about saving travel time, saving errors because of or just delays because people don't have the right expertise? Are you planning to measure those kinds of impacts?
Yes, actually we've estimated those impacts with one of our pilot projects, and now in the coming months we'll try to really measure them and to really test that our initial hypotheses were accurate. But yes, in terms of saving time, in terms of whether it's just simply to send the expert to the final assembly line or to the place where that expert advice is required, and also reducing the number of errors, AR should have a significant impact. Hopefully in the coming months we'll be able to give you hard figures that will prove that statement.
Exactly. Thank you. And Joe, you mentioned previously that you were also talking about the speed with which production lines could be converted to other products, reduction in the time necessary to inspect, making sure that all contaminated or different kinds of ingredients are removed. Do you have any other ideas or any suggestions about impacts? Where will Johnson & Johnson Vision Care be looking?
So the project that we're working on currently with helping move AR technology to manufacturing, we've identified three main items to measure for the impact of this technology, and that is just the reduction in unplanned downtime, also the increase in setup time for a manufacturing line, and just improvement in quality. So I figure with those three metrics that we measure will certainly tell us the true story whether or not this technology is something we want to move forward with or not.
Great. Okay, gentlemen, the last question is, what signs are going to, that's just a beautiful transition, Joe. I couldn't have scripted that. Asking you what signs will indicate to decision makers that augmented reality is ready for wider deployment. Some of it is hard metrics. Any other ideas, Paul? What do you think are those signs that you're looking for, or that your executives are looking for before they're going to start investing in wide scale deployment?
Well, I mean, I think I could probably reel off, 5 or 10 kind of technical requirements that we should meet before we can claim that it's ready for deployment, and we can, give ourselves a gold star for meeting those. But I think probably more importantly is when you get more pull from the end user than you do push from the technologist. And when you've done your first pilot, and then the pilot closes, and then the people on the shop floor are saying, "Hey, I need that AR tool. Where is it?" Or I really can't do this without AR now, that kind of thing. I think once you start seeing those signals, they probably encapsulate, the majority of what's needed before wider deployment is probably suitable. And of course, once executives see that kind of thing too, I think they would agree.
Right. And Newport News Shipbuilding, you've seen that kind of people coming to you and asking for participation in a pilot or proof of concept. Is that right, Patrick?
That's right. Those are some of my proudest projects, are when someone calls me and says, "Hey, I need AR, get down here." And so that is starting to happen, and that's a great indicator that we're starting to get some wider deployment, and certainly at least wider recognition. I will echo what Paul said on getting some technology check boxes checked off. And then there are also some things beyond just technology limitations that are in the kind of the policy and procedure regime. How can I bring cameras into an area where we build rather sensitive projects, and how are we going to handle the infrastructure of protecting data if we're using wireless delivery of information that belongs to not us, our customer. And so some of those things are actually the bigger barriers to entry for large-scale deployments. And that's one of the reasons that Newport News Shipbuilding is very interested in joining with the area, to see how others are solving some of those policy procedure type problems, and how we can all work together to get our own businesses to scale this technology.
Great. So I'd like to ask if anyone on the call, any attendees, any of those of you who are joining us today, have any questions you'd like for the panelists to address before the end of our webinar. One question that's come in, there were a couple of mentions of it. Paul, you and Patrick both mentioned in the last few minutes that you had a list of 5 or 10 technology hurdles that you'd like to see overcome. Could you share with us, what are the top 5 technology hurdles? I suspect one of them has to do with wearable technology, but let's see, Paul, could you take a stab at that?
Sure, you suspect correct, Christine. One of the big ones is, obviously maturity of see-through displays. Patrick mentioned all of their work has been on tablets, and we're in the same situation. All of our pilots currently use tablet PCs. And a consistent comment that you get when you show, or when people start using it, is, "Hey, this would be great if I could have it on a head-mounted display, if I could have my hands free." And it's, I have to keep, they see Google Glass and things in the news, they hear augmented reality mentioned on the news, and they, sometimes folks don't understand why we can't put what we do on a head-mounted display, and I have to explain some of the challenges. So things like field of view are continued problems, battery life, brightness, fidelity, things like that. Also, the social aspects of head-mounted displays are pretty, I would say, not well understood. Also, we still have a lot of work to do with tracking. We want to avoid, if we can, using fiducial markers or any kind of infrared tracking system. We want ubiquitous tracking systems that will work throughout the factory and even outside of the factory. So I think we have there's a lot of work to do there. I think a third one would be connection or interface to enterprise systems. A lot of what we do, we take content and we manually prepare it or process it for augmented reality. But our augmented reality technology is not fully integrated into things like MES and our ERP systems, and that has to happen also. So even though we're able to show good results and do these pilots and make people smile and everyone sees, the kind of the sexy side of augmented reality, I think there's a lot of work to do on the rest of it to make it a true scalable enterprise system.
Right. Thank you. Another question, I mean, if anybody wants to chime in on the technical obstacles, I won't stop you. Anybody want to?
Yeah, I got a couple more, Christine. Paul took my top three, wearables, markerless, and delivery. But a couple other things that are of interest to us is increasing the accuracy of placement. We're entirely mobile. We rely on the camera exclusively. And so understanding how accurately you can place a part or do an inspection is really important to us, and so it ties into the vision science. And the other thing that's still I think is a struggle for adoption is understanding kind of depth of field issues when you're doing an augmentation without any kind of depth sensing. So what I'm talking about is occlusion. If you're familiar with how AR works, you'll render a geometry on top of the screen, and the computer has no understanding of what's in the foreground and background. So in the situations that we work in, we have temporary ventilation and ladders and all kinds of things that appear in the foreground that should be in front of your rendering, and the vision science technology that we rely on still can't sense that. And you need another sensor on the tablet, or you need another way to sense depth. And so I would add those two, accuracy and occlusion, to get your list of 5 technology barriers that need to be addressed.
Okay, great. I'd like to ask a question now from an attendee asks about labor legislation or regulation, labor unions, in particular thinking about the question is targeting European country deployments. When you go across different countries and different industries, there might be different conditions. David, have you guys done any research or have any open items or items that you've closed that pertain to regulation and labor policy in your environments? Because you work with a lot of experts.
Yeah, I would highlight a couple of points. One is obviously privacy, and even if it's in the workplace, whenever we bring to the line cameras or any device that allows video recording of the actions of anybody, that raises a lot of issues and creates susceptibilities from the point of view of the technicians or the people involved in that task. I guess that humans not, or usually, at least in these environments, people don't like to be monitored, don't like to be, I guess, followed up very closely. And yeah, when we're dealing with unions and things like that, that can create some issues. The other issue that I'd like to point out, and it's probably not linked to regulations, but to I guess the personal adoption of these kind of technologies, is that in some cases the technology is not ready to create an easy-going experience from the point of view of all the physical annoyance that it can create in terms of dizziness, motion sickness, and things like that. And that's something that needs to be resolved, and that's probably why, or another reason why, the technology of choice so far usually is tablets, because they don't tend to create those problems. And although again it steps away a little bit from this topic when we're talking about regulations or security policies, that's something that somebody mentioned before is also a big one for us, because it's hard to bring these kind of technologies to industrial environments with a lot of security restrictions, because in the end you have the possibility of taking away from the site and from that company a lot of sensible information, and you need to be mindful of that.
Right. And in some cases, there may be very common sense and valuable regulations and policies, but they haven't been written. And because the policy doesn't exist, we don't know where we stand with respect to those best practices. One of the other questions that's coming up from our attendees is about costs. We've spoken indirectly about return on investment and directly about measurable benefits. But could any of the panelists speak about the cost for development, maybe the estimated cost per app or per use case? I guess it's a kind of a delicate thing to disclose, but Patrick, could you, so much experience and so many pilots, have you got some guidelines that you can give about how much it costs to develop another use case?
Yeah, that is a delicate question. It's also a dangerous one because I hate to put numbers on uh, development of anything because everything is so unique, and almost everything that we do is very custom. So there's a big it depends, and
Mm-hmm.
then there's a big well, it's also that's a pretty sensitive piece of information that typically
Yes.
we don't share. But what I will share is that we have in excess of 20 people here at Newport News that do augmented reality full time for a living. Um, so you can kind of take that for what it's worth and scale that out. And um, a typical project for us will generally take 2 to 3 months from conception to delivery. Um,
That's good. That's good to know. That's a
so
very
that,
helpful, valuable. But keeping in mind that this is an engine that's now running for several years,
that's a
doing this
fact. And we're 5 years into it, so that you also need to factor that in. We can, we kind of know what we're doing at this point.
right. So out the gates, it's not going to be 2 or 3 months. It could be double or more. Does anybody else have anything they want to share regarding the potential or real costs? Any insights about how if you're using an outside provider, how do you calculate that? How do you what are the parameters? Is it the number of images? Is it the number of models that are used? Or the number of targets? Paul, do you use any outside engineering services?
We do, but not kind of for end-to-end augmented reality technology. We develop a lot of it ourselves. I would say, what we've developed, I've tried to make it as non-program specific as possible, so it can be used across other programs. For it can be replicated, I should say, for as low cost as possible. And what I do tell folks when they want to know how much it's going to cost to bring AR to their program, the driver of the cost in our world is the tracking system used. We do everything from 2D printed marker-based tracking, which is obviously next to nothing, all the way up to 15 camera Vicon systems, which can run into the hundreds of thousands. So the tracking technology, from our viewpoint, is by far the biggest driver of cost of implementing.
Well, that's very insightful. That's very good. So some questions, some people from the audience are asking if any of those on the panel today provide commercial services for third parties. Like, can we hire your team to do projects in their companies? And I guess that is the case, perhaps for some of the spin-offs. And Newport News Shipbuilding, you got such a good team that you want to fill in that question and
Sure.
explain what's available commercially?
I'd love to field that question. So yeah, about a year ago, Newport News signed a teaming agreement with a third-party technology startup called Index AR Solutions. IndexARSolutions.com if you want to check them out. And they basically have a lease teaming agreement with my team. So any commercial work goes through Index, and you can get access to the folks, knowledgeable folks here at Newport News, to go execute commercial contracts or commercial work or deployment of solutions at your place through our team and our technology.
Okay. Well, and I'd like to say on behalf of the many area members who are not part of this panel today that some of the area members are very qualified and can bring those kinds of solutions. Since I know that the slides were not visible when I was showing earlier, I now have on my screen the logos of our 22 members. They represent a very geographically dispersed and very excellent services that you could turn to for consulting or for engineering work on these kinds of projects. Some of them are experts in the head-mounted displays or delivering head-mounted hardware already. Others are providing software and different kinds of services that can be beneficial for a deployment. Also, I think that I just recently wrote a blog post about that subject, so I do want to encourage people to visit the website of the area, thearea.org is how it's spelled. If you haven't been there, please do take a visit and spend some time with us. I think we're out of time today. I want to thank our panelists once again for their valuable contributions, great insights, really well articulated. Thank you so much, gentlemen, for your participation. Thank you to our attendees for your attention today, and I look forward to hearing more from you in the future. If you have any questions, do reach us. Let me put my email address up at the front of this is not there. So my email address is simply Christine, CHRISTINE, at thearea.org. And I can help you get in touch with any of our panelists if you would like to follow up directly. Thank you once again, everyone, and wish you